So let's do a little review of what polar equations are. So remember, polar coordinates are just a different coordinate system than Cartesian, our normal rectangular coordinates. So instead of having an xy coordinate pair, right, so like this equation stands for x, this equation stands for y, right, polar coordinates are graphed with the radius, so the distance from the pole, which is the origin, and then theta, the angle from the positive x-axis. Right, so the connection between the two is that x is just equal to r times cosine of theta, and y is equal to r times sine of theta. That comes right out of right triangle trig. Right, and then the connection between the two, you can always find the radius if you know x and y because of the Pythagorean theorem, r squared equals x squared plus y squared. Right, derivatives are pretty easy. Remember that you just take the derivative of both the x and the y equation in terms of theta, and then you divide dy d theta over dx d theta. So you're just putting the two equations on top of each other. So we're going to go through and do a quick little review about that. So quick little review problem, no calculator. A polar curve is given by the equation r equals 2 plus 3 sine of theta. What is the slope of the tangent line when theta equals pi? Right, so if they ask for the slope of the tangent line, they're asking for dy dx, right? So clues us in that we just need a regular derivative, dy dx. Okay, so we know that y is equal to r times sine of theta. So that's going to equal 2r, so that's 2 plus 3 sine of theta times sine of theta. I'm going to leave it factored out like this because I prefer that. And then x is equal to r cosine of theta. So x is going to equal 2 plus 3 sine of theta times cosine of theta. Right, and now we're just going to take the derivative of both with respect to theta. So dy d theta, we're going to need to use product rule here. So derivative of the first is going to be 3 cosine times the second, so times sine, plus the derivative of the second, so cosine, times the first quantity, so 2 plus 3 sine of theta. If you want, you can manipulate this algebraically. That's kind of how my brain instantly wants to do it, so I can factor a cosine out of both parts. So I get cosine of theta times 3 sine of theta plus 2 plus 3 sine of theta from the second part. Right, so this derivative is actually cosine of theta times 6 sine of theta plus 2. Now you don't have to do this, especially because you're told the theta value. So we know that this is dy d theta, and I want to evaluate dy d theta at the theta value of pi. So cosine of pi is -1, 6 times sine of pi is 0, so plus 2, we're going to get -2 here. So there's the first part of the derivative, totally done. And now we do the same for our x's. So dx d theta, right, derivative of the first, so we get 3 cosine of theta times the second, plus derivative of the second times the first. Now there's nothing easy that I can factor out of that, so I'm just going to kind of make it a little nicer looking. So 3 cosine squared minus sine of theta times 2 plus 3 sine of theta. You could also distribute through if you wanted to. So then I want to find not dy, because this is an x, dx d theta at theta equaling pi over 2. Not pi over 2, just pi. Wow, okay. Right, we're going to use the same angle, obviously. So 3 times -1 squared minus 0 times 2 plus 0. Right, that's still 0, doesn't really matter. 3 times -1 squared is going to give us 3. So my overall derivative, dy dx, at theta equaling pi is just -2 over 3. Now, say you wanted to also find the tangent line, right? So if we wanted to find the tangent line, we also need to plug in. So let's just go ahead and do a little bit of extra work here. So we have x of pi is going to equal 2 plus 3 sine of pi times cosine of pi, as long as I remember that correctly. Yep. So we've got, that is 2 plus 0 times -1. Okay, so we get an x coordinate of -2. And then y of pi is going to be 2 plus 0, right? 3 sine of pi is still 0, times sine of 0 sine of pi, right, rather, which is 0, so it doesn't really matter. So we get 0 here. So if we wanted to write the tangent line, you need to use the xy coordinate pair. So the tangent line at theta equaling pi is going to be y equals, we had our slope of negative 2/3 times x plus 2. And now, how about this? How about we actually just graph that and see what that looks like? So we have Desmos very slowly loading, and I'm just gonna make, can I make this full size? No? Okay, hang on, there we go. Okay, so we had the equation of, let's see, we had r equals 2 plus 3 sine of, nope, they're not gonna make this easy, okay. So theta, and then our so it gives us, that's a limacon, remember, limacon, however you want to say it, trying to zoom in there. And then our slope, our tangent line was y equals negative 2 divided by 3 times x plus 2. Oh, x plus 2, there we go. I was like, why isn't that working? There we go, now we can see that it is tangent, and that is going to be the point, right, that's the angle where it's pi, because that's the negative x-axis then, so